All right, so in this recording, we are looking at section 4.4. Section 4.4 is all about exponential and logarithmic equations. So in 4.4, again, exponential and logarithmic equations. I'm just going to put log equations, EQ, just to keep things moving along. There are 11 examples, but I promise you they're brief, so if you could just bear with me, I will assist you in understanding this. So the first example, example 1, talks about how we can make the exponent equivalent should we have the correct or the same base in this case. So as an example, if I have b to the m power, and this is equal to b to the n power, then by default, m is equal to m. M is equal to n. So here's an example. In example 1, they give us the direction to solve. And the direction is 2 raised to the 3x minus 8. And this is equal to 16. This is where knowing your powers and your bases comes in handy. We know that 16, as a result, is equal to 2 to the 4th power. So knowing that, we know that 2 raised to the 3x minus 8 equal to 2 to the 4th power means that now we can focus on solving this part of the equation. So we take 3x minus 8, and that's equal to 4. If I add the 8 to both sides, notice that this is going to cancel. We're left with 3x is equal to 12. Obviously divide by 3 on both sides, and therefore x is equal to 4. And so in our example, x equal to 4 is the solution to this equation. So we would write it in set notation. And so very simply stated a 4. Example 2 that they give you here, let's call it B. We have 27, and that is raised to the x plus 3, and that is equal to 9 raised to the x minus 1. So think of a number that could be a base to both 27 and 3. I'm immediately thinking that 3 squared. So notice that I'm doing 3 squared x minus 1. So that becomes a product. And therefore 3 to the 3rd. Again, you need to know your bases. If you don't by now, and this will help you on the SAT and ACT. Since now I have the same base, again, I'm going to focus on this top line, the exponents. And I'm going to set this and solve this. So this gives me 3 parentheses x plus 3 is equal to 3 raised to the 2. I'm sorry, I'm making a mistake already. Because that's a 3, so I thought this was a 3 also. I'm looking at this wrong. This is actually 2 parentheses x minus 1. Again, we're just focusing on just this top line, right? So now we have 3x plus 9 is equal to 2x minus 2. And so we need to solve for x. So the first thing I'm going to do is I'm going to go ahead and I'm going to subtract the 2x on both sides. I'm going to subtract the 9 and move it to this side. So if you notice, the 9's cancel, the 2's cancel, and that leaves you just x is equal to negative 11. Your solution set for this equation is simply negative 11. So I would like for you to take a look at these two and then give this a try. I'll give you a couple of minutes to answer these. And I'm going to give you, let's call these C and D respectively. So this will be 5 raised to the 3x minus 6. And this is equal to 125. And in D, I'm going to give you 8 raised to the x plus 2. And I'll set this one equal to 4 raised to the x minus 3. I'll give you, like I said, a couple of minutes. This should not take you very long. Okay, since I flunked 4th grade and never went back, I don't know time, so we're going to start now. So here's your solution. 5 raised to the 3x minus 6 is equal to 5 raised to the 3rd. We know that because 5 times 5 is 25, and 25 times 5 is $1.25 if you think of it in terms of a quarter. And so now that we have the equivalent bases and now their exponents, we're now going to solve for our equation. And so we have 3x minus 6 is equal to 3. Right? So we focus on just solving this equation up here. So if I add 9 to both sides, make that 6. If I add 6 to both sides, sorry, I was looking at another question while I was actually writing this. All right, this leaves us with 3x is equal to 9. I'm dividing by 3 on both sides, and this will cancel, leaving me x is equal to 3. And that is your solution for this equation. Again, we write our solution in set notation. Same thing for this. This is 2 to the 3rd. This is raised to the x plus 2. We know that because 2 raised to the 3rd is 8. This is equal to 2 raised to the 2, parentheses x minus 3. And so if you note, we have the same base, so now we just focus on the exponent. Because of equivalence, this becomes 3 parentheses x to the 2 is equal to 2 parentheses x minus 3. So if I distribute the 3, distribute the 2, I get 3x plus 6 is equal to 2x minus 6. One more time. So what we're going to do is we're going to swing this over to this side. I'm going to subtract the 6 on both sides. And so this leaves me x equals negative 12. Remember, these two are canceling. This is canceling and this is canceling because it's plus and minus of itself. Final solution, negative 12 for this one. All right, any questions, let me know. I'll stop for a second to take questions. Let me know. All right, so now I'm going to move on to example 2. In example 2, we are solving exponential equations. And so what they give us here is 4 raised to the x is equal to 15. Now I want you to stop for 1 second. And just think of the fact that we know, so we know that 4 to the 2nd is 16. So we can estimate that this value, this x that we don't know, we can estimate just by looking at it that it's going to be pretty close to 2. With that said, we're going to drop the x and we're going to simply set it as the log of 15 over the log of 4. When you do this, you will obtain your answer. And in this case, once you do this, x is approximately not exactly, but approximately 1.95, because we are rounding that number as well. Okay, and you notice again, it's pretty close to 2, but not exactly 2. All right, so that's something I want you to consider once you learn your bases and you're really comfortable. This is the first of example 2. This is the second one. In the second example, we have 10 raised to the x power is equal to 120,000. So what I want you to do whenever we have something like this or a question like this, I want you to place log in front of both values. So in this case, this becomes log of 10 to the x is equivalent to log of 120,000. Because you have log on both sides, we can now, and now I want you to remember this is a 10 here, right? So you're left with 10, this is just x, right? Because 10 to the x is x. Remember that rule that we went over and with the log of the base? Let's put the 10 here, right? For example, since, oh actually no, let's do, I don't like that. This is going to confuse you more than help you. So let's just use this example. Since we know this base is 10, and I have 10 to the x, then this has to equal x because 10 to the x is 10 to the x. It's that loopy-loop thing that we do, but you isolate just the left side to do it. So that gives you x is equal to the log of 120,000. Which we know this is gonna, once your calculator is done, we get x is equal to 5.08. We also know that if I had log of 100,000, that this will become log 6 because this is 10 down here. And so that's equal to x. So that means that 10 to the x is equal to 100,000. And therefore x is approximately 5. Right, because we have 5 zeros, so 5. Okay, so that's just a little help. Here's what I want you to do. Let's try 2 more examples. We'll call them C and D respectively. So C. In example C, I have 5 to the x is equivalent to 134, and in D, I have 10 to the x is equal to 8,000. Okay, I'll give you a minute to do that. So I want you to remember that 5 times 5 times 5 is 125. That means 5 to the third is an approximation. And so again, x is equal to the log of 134 divided by the log of 5. And you should obtain approximately 3.04. Because it's just a little bit more than 125. Okay, so as a guide, just remember 5 to the third is equal to 125. This is why knowing these bases is so important, especially when you're doing a SAT, ACT, you can estimate and move on. Because they're going to give you multiple choice on this very likely. Okay, example D. So what happens here is we're going to place log in front of both of these, right? And so in doing so, we remember that there's a base 10 sitting here. So log base 10. Again, remember the theory is this. There's a little base 10 that we don't write because we assume it's there. And so 10 equal to what makes this equal to what? Well, 10x, 10 raised to the x is also equivalent to 10 raised to the x. So this has to be x is equal to. Again, this is equal to what? So we're looking at log 8,000. So again, using common sense, this should be close to 4. Okay, and so in doing so, since I'm looking at log of 8,000, literally put this into your calculator. The log of 8,000, well, that's going to give you an output of 3.90. And these are intended for you to use the calculator. All right. Let's go with example 3. In example 3, we're still solving an exponential equation, except this time we have natural base e in this particular example. So we are solving an exponential equation. Let's do EQ. And so we have solve as the direction, solve, and then they give us 40 e raised to the 0.6 x minus 3 is equal to 237. So there is no way that you can't solve this unless you work out the equation first. So I'm going to begin by adding the 3 on both sides. This gives you 40 natural base e raised to the 0.6x is equal to 240, right? Because I'm adding those two numbers. Next thing I'm going to do is I'm going to simply divide by 40 on both sides. So this will cancel, and this leaves me with natural base e raised to the 0.6x is equal to, in this case, 6, because 240 divided by 40 is 6. I want you to consider at this point that you're going to basically put natural log, place natural log in front of both of these numbers. Remember that I said to you, when you do that, this natural log and the natural log base, or the natural base e, will cancel themselves. This then leaves you with 0.6x equal to natural log 6. And to solve for x, all you have to do is divide by 0.6. Okay, so that crosses out, leaving you x is equal to the natural log of 6 divided by 0.6. Again, this, however, you will not have anything to memorize. You literally just use technology. So x is equal to 2.99. All right, so that's the whole question. Take a picture if you need to, or add additional notes, and I'm going to give you a try question. Again, there's nothing new about what we're doing here, technically. All right, so let me give you the try question. You should have this by now, and any questions you have, ask before I continue. Okay, so the checkpoint question. So try this one. We'll call it question B. Question B says solve. They give us 7e raised to the 2x and then minus 5 equal to 58. All right, so the first step you should have taken, they're giving you pretty numbers, because when you add 5 to both sides, this 5 cancels and this leaves you 7e raised to the 2x is equal to 63. We're then dividing by 7 on both sides. Once we divide by 7 on both sides, we're left with e raised to the 2x equal to 9. Again, the trick to this one is place natural log in front of both. Okay, and so once again, remember, natural log and natural base e will cancel. That leaves you with 2x is equal to 9. Natural log of 9, I'm sorry. And then we're going to divide by 2 on both sides to cancel out the 2, leaving you x is equal to natural log 9 divided by 2, which approximates 1.10. Okay, so that should not be terrible if you're fairly decent at algebra 1, even algebra 2. All right, so let's look at example 4. In example 4, we have, again, solving. Nothing's changing. We're still solving. It's just different types of problems that you're going to face. So draw solving an exponential equation. And so they're asking us to solve 5 raised to the x minus 2 equal to 4 raised to the 2x plus 3. We've got a problem here, folks, because we don't have the same base. We have a base 5 and a base 4, and there's no way to equate it. Except if you take the natural log on both sides. So we'll do natural log on both sides. That's step 1. Once we do natural log on both sides, we are now going to use the power rule. Okay, so I'm going to write power rule to remind you. In the previous video, you noticed I accidentally wrote product rule, and I was describing power rule. Medication. Blame the medication. I had a really bad cold yesterday. So I'm bringing the power in front on that side to give me x minus 2 times the natural log of 5. This is equal to 2x plus 3, again, power rule, moving that forward, times the natural log of 4. Okay, so what we're going to do next is we're going to distribute. We're going to distribute this here and here. We're going to distribute again here and here. So what this becomes is x natural log of 5 minus 2 natural log of 5. We're going to set that equal to the other side, the right side of the equation, where we have 2x natural log of 4 plus 3 natural log of 4. Now, if you notice, there are two parts of each equation that have an x, and this is what we're interested in. So what we want to do is we want to bring the x's to the left side of the equation or the opposite, and then do the same thing with the other one. We're going to move it to the opposite side so that they're both together. So in other words, if you notice, this is 2 natural log of 5. This is 3 natural log of 4. And therefore, we're going to group these together simultaneously. If I subtract the 2x natural log of 4 and bring it over here, all right, so if you notice, I'm going this route, so I'm canceling it on this side. I want to then add 2 natural log of 5 on this side. All right, and so now that we have this group together, we have negative x natural log of 5 1 second. Okay, sorry for the interruption. Let me go back, open this up. Okay, so what we have here is x natural log of 5 minus minus 2 x natural log of 4. So I'm basically just taking these two and putting them together into an equation, setting that equal to 3 natural log of 4 plus 2 natural log of 5. Now, in this case, I need you to understand our key goal is going to be to get that x out of here. So we have x equals. So very simply, if I take x out, I'm left with natural log of 5 minus 2 natural log of 4, and this is equal to the 3 natural log of 4 plus 2 natural log of 5. To solve for x, I'm simply going to divide by natural log of 5 minus 2 natural log of 4 on both sides. And then this will cancel to 1, and therefore x equals all of this stuff. You can actually solve for this by tossing it into a calculator, and the solution for this should be approximately negative 6.34. So I'm going to give you a minute to throw that into the calculator and see that you get the same numbers that I did, and then I'll resume the recording based on your completion. All right, if you need further assistance or questions, please ask before I continue with the next try example. So I'm going to go ahead and get started and write this down. So please try to solve for this. This is 3 raised to the 2x minus 1. This is equal to 7 raised to the x plus 1. All right, give you a minute or two to solve for this one. All right. Now, again, I'm going to walk you through the steps. Tell me when, tell me if our answers match. So the first thing I'm going to do is throw natural log in front of them. So if you notice, this is my first step. So step 1, natural log, both. Step 2, power rule. Okay, so I'm going to take all of these values that are exponents here, and I'm going to place them in front of the natural log. So this gives me 2x minus 1 natural log 3 is equivalent to x plus 1 natural log of 7. All right. Next thing I'm going to do in step 3 is I'm going to distribute. When I distribute, I'm distributing to both terms. So I'm going to get natural log of 3, or 2x natural log of 3, minus natural log of 3 is equal to x natural log of 7 plus natural log of 7. I'm now looking at which terms have an x. So both of these have an x and these two do not. So I'm going to add natural log of 3 and cancel it over here and bring it to this side. I'm going to cancel x natural log of 7 on this side, and I'm going to bring it over here as x natural log of 7. Now understand, I'm writing this for you step by step. There are so many steps you can do in your head and just get the answer, or at least get to the point where you can actually solve this. So just keep that in mind. I know some of you are probably stressing, and others of you like the steps. So here you go. I'm giving you the steps. You decide how you want to skippity doodle around this, okay? It's all up to you. So over here, this is what we have. We have natural log of 7, natural log 3, and obviously what I want is I need that x. And x is now available to me on both sides. So if I do that, I can now extract the x, and this will leave me 2 natural log of 3 minus natural log 7. And this is now equal to the natural log 7 plus natural log 3. Dividing by 2 natural log 3 and natural log 7, negative of course, on both sides. So it cancels on this side. Now I can throw this in the calculator, which I recommend you practice this as often as you can. All right. Let me stop here. I have a student coming in for tutoring. Resume. All right. So looking at that example, I want you to try another one. So this is our final answer here. Do you have any questions on that, by the way? All right. So I think we're doing good. So let's do example 5 here, and then I may or may not switch videos because sometimes the Movavi gets exhausted. So example 5, it is the same question again. So we're still solving, it's just another type. So we're solving, again, an exponential equation. And so we're going to solve e raised to the 2x minus 4e to the x plus 3 is equal to 0. Okay, so I want you to stop for 1 second. And I want you to remember a rule that if I multiply e times e, the result is going to be 2x. Or I'm sorry, x times x is going to result in 2x. So you're going to treat this like if it were factoring, but you're factoring literally along the exponents, but yet at the same time looking at the coefficients. I know it may sound like a crazy experience, and it is. So this is really the result of e to the x times e to the x. So in other words, e to the x times e to the x gives you 2x's, so therefore e to the 2x. I need a 3 and a 4 for the sum, a 3 for the product. This is a negative, so this has to be, first of all, a double negative and a 1 times 3 because it's a prime number. That's all you've got. So when you multiply these, just to prove it to you, e to the x times e to the x is e to the 2x. Inner, outer is e to the 4x. Negative 1 times negative 3 is positive 3. Okay, so I need you to remember that process. And if you need to replay this, you can. That's the beauty of a recording. So I decided to record these chapters because there's 2 camps in this particular class. There are students who have been exposed to this and students that have not. And so it helps that you guys are seeing this, and you can go back, repeat it, and so on, right? Okay, so now we have basically 2 equations. So I'll start over here with this one, where I have e to the x minus 1 is equal to 0. And on this base camp, I have e to the x minus 3 is equal to 0. If I add 1 to both sides for this one, I get e to the x is equal to 1. Therefore, x has to equal 0. Use your calculator. You'll understand why that is so. Okay, and so in this case, if e to the x is equal to 1, x is equal to 0. We know this because you have to understand the behavior of 0 with respect to natural log. You'll see what I mean. So this is always going to be this answer. So you can just record it in your brain as a rule. Now here I'm left with e to the x is equal to 3. Notice I left a little space. And that is because natural log e to the x is equal to natural log 3. Again, remember, natural log and natural base e cancel each other out, leaving you just x equals natural log 3. If that's natural log 3, then your two solutions in this case are going to be 0 and natural log 3. The natural log and e are very unique numbers, and so play with it. When you solve for natural log 3, by the way, natural log 3 is approximately 1.10. Any questions? This is a good time to ask, as any. Okay, let me have you try another question. I would like for you to try solve e to the 2x minus 8e to the x plus 7 and set that to 0. Again, the process is no different here. I'll just give you a little start hint. All right, so I know you guys would have immediately done e to the x and then e to the x because you know that gives you e to the 2x. You know that because this is negative and that's positive, that you have a double negative. 7 is a prime number, so we know that this is a 1 times 7. Added together, -1 and -7 will give you -8. So we proved it, right? So now we solve e to the x minus 1 is equal to 0. E to the x minus 7 is equal to 0. And so now we have e to the x is equal to 1. And here is e to the x is equal to 7. All right, and so obviously we remember, right, that what would make this equal to 1 is if x equals 0. Remember, anything to the 0 power is 1 anyway, right? That's an easy rule to remember. Here, we know that x is equal to, technically it's going to always be natural log of 7. But if you want to do this the long way, I can do this the long way for you. It goes like this. Place natural log in front of both. Natural base e, or natural log and base e cancel. And now you're left with x equals natural log of 7. Two solutions for you are 0 and natural log 7. All right, and then if you throw this in your calculator, you know the natural log 7 should be close to 1.95. All right. So let's do now, this is the equivalent of, what did we finish? Example 5? I think we could finish example 6 on this. In example 6, we are solving Now we're solving logarithmic equations. So I'm just going to put log equations. And so as a rule, I want you to remember what I taught you, which was the example, if I have log base 2, 8, that is equal to 3 because 2 to the third is 8. If you can remember that model, it's a lot easier to remember, in my opinion, than listening or looking at something this basic. But if you want to look at this as a model, then we can use this as well to guide us. So I'm going to start with example A, which is going to look a little ominous at first. And by the way, it doesn't matter if you're doing natural log or log, either one. This process will work for you. So when you look at this equation, initially it's like, well, where do I start? Very simple. Start with drawing a backward C. That means that 4 raised to the second is equal to x plus 3. 4 to the second is 16. That's equal to x plus 3. If I subtract 3 on both sides, this is 13 is equal to x. And that's your answer. You want to check it? Throw the 13 back in here. This is 16. Is it not true that 4 squared is equal to 16? All you're doing is throwing that back in here. All right, that should have been fairly easy to follow, I hope. Any questions, please just chime in. I stopped the video, we could talk. Log B, I have 3 natural log of 2x is equal to 12. Actually, I placed the parentheses here. All right. When you have a question like this, I want you to just think algebra, because all you got to do is follow the steps where we divide by 3 on both sides. Notice that cancels. Notice you are now left with natural log of 2x is equal to 4. I also want you to remember with natural log, what sticks. You guys asked me this question, and I answered it. I don't think you remember or understand why I said what I said, but this is why. You see how the base here is e? And so we're going to re-express this as e to the 4th is equal to 2x. So e to the 4th is equal to our 2x. I'm solving for x. I'm simply going to divide by 2 on both sides. So x is equal to e to the 4th over 2. You can always prove it by working backwards. So to prove that this is true, you would say 3 natural log of 2x, which is now e to the 4th over 2, is equal to 12. Well, 2 things are going to happen here. The 2's are going to cancel because this is 2 over 1 times e over 2. They go away. Natural log and e are going to cancel because this is going to drop as natural log e to the 4th. Remember, they cancel. You're now left with 3 times 4. Isn't it not true that that's equal to 12? Remember, this is times. All right, so you proved it. All right, let me give you 2 try questions. I'd like you to take a minute. We'll call them C and D. So I'm going to start you with log base 2 of x minus 4 is equal to 3. On D, we have 4 natural log of 3x is equal to 8. I'll give you 2 minutes. You know, Barrazo style 2 minutes, which could be 30 seconds. I think you have had enough time. That's my opinion, but if you need more time, let me know and I'll stop. But if not, I'm going to continue. First thing is raise 2 to the third and set it equal to, so 2 to the third is equal to x minus 4. 2 to the third is 8, and that's equal to x minus 4. And if I add 4 to both sides, then I have x is equal to 12. Woohoo! Done, son. Remember to always write these solutions in a solution set so that may impede you if you don't on the Pearson homework. All right, for the next question, remember this is natural base E. And so when you solve for this question, we know that if it's natural base E, this also is, this should result, by the way, in e to the second over 3. I'm going to wait 1 second to see if anybody needs a little bit more time. All right, so I've given you a little bit of time to think about this. So the first step you're going to take is divide. We're going to divide by 4 on both sides. That's step 1. This is going to leave you natural log of 3x is equal to 2. Anytime you divide by natural log, which is what we're going to do here, this becomes 3x is equal to e to the second. Last thing we're going to do is we're going to divide by 3 on both sides. So that's your answer. X is equal to, as I stated earlier, e squared divided by 3. All right. And as you can tell, that was similar to the last equation we did. All right, and so the next question that we have here is example 7. This is solving a logarithmic equation. And so we have solve log base 2x plus log base 2x minus 7, and this is equal to 3. So remember when we did the product, and I said to you, if it's a product of logs, it's actually the addition of the exponents, which is the addition of the log, right? Because that's what these are. These are exponents. So this becomes log of base 2, because I can extract that. That is common to these two terms, right? So I'm going to leave this as log base 2. And then our product is x times x minus 7 equal to 3. And so as crazy as this may sound, all you're going to do is apply that backward c. So 2 to the third is equal to all this. So now you have 8. Well, let me write it out. So 2 to the third is equal to x times x minus 7, basically. So now you have a trinomial because all you have to do is solve for each of these. So this is x squared minus 7x. And now if I subtract the 8 on both sides, this will give me 0 is equal to, right? I just have to factor this. So I'll get x minus 8 and then possibly x plus 7 or x plus 1 to get 7. So that gives me negative 8. As a sum, that gives me negative 7x, x squared. So yes, that's good. So x minus 8 equal to 0 means that x is equal to 8. X plus 1 equal to 0, however, means that x is equal to negative 1. And so you need to understand we never have negative logs. So just by default, because that's a single, I don't think that would work. Because you would have log base 2 of negative 1. Right away, that would not check. So don't even bother with any negatives. Now, if you have an equation in here, that might work. All right, and so the equation would be something like, you know, if I had, say, 2 minus x. So that if this were log base 2 of 2 minus x, and I substitute a negative 1, so this is 2 minus 1, that's a 3, right? Because those two become a plus. So that would work. So always check is what I'm getting at. Don't assume. Check. Check, because if it's an equation, it might actually work. So the only solution here is the 8. That would work anytime because you could have log base 2, 8. Okay? So having seen this equation, I would like for you to try one more. We're going to look at log x plus log of x minus 3. And this is equal to 1. I'll give you a few minutes on that. I think I'm going to do one more example after this one on this tape, and that's it. The rest are substitution. I will do them with you on a separate recording, or if I continue on this recording, depending on how much the tape will hold, I will then consider just doing the rest of this video with you, or you could do it on your own too. So in this example, we're going to do log of x times x minus 3 equals 1. Remember, this is a base 10. So this is really 10 to the 1 is equal to x squared minus 3x. All right, if I subtract the 10, I'm left with 0 is equal to x squared minus 3x minus 10. My solution set here will be x, since it's a negative, and that's a negative, it's a mix. So possibly x minus 5, x plus 2. So this will give me x is equal to positive 5, and this is x is equal to negative 2. I can guarantee you this will not work, this will. So your solution is 5. And you can throw that into the equation and solve. You'll see what I mean. All right, so that's number 7. Let's do number 8. I think we can make it happen. Okay, so when x is equal to 8, I have solving a logarithmic equation. And so I have solve the natural log of x plus 2 minus the natural log of 4x plus 3. And this is equal to the natural log of 1 over x. This question is not difficult, it's just long. Very long question, but very easy at that. So we're given an equation. Here's what we do know. We know that this is a difference. Remember, difference is division. So we really have the natural log of x plus 2 over 4x plus 3. And this is equal to the natural log of 1 over x. Well, guess what? Even though it looks ominous, the natural logs cancel. It's that simple. So what we're going to do is we're going to use this as a denominator. So basically, you're going to end up with x plus 2 over 4x plus 3 equal to 1 over x. I'm going to multiply on both sides, respectively, by the entire denominator. So I'm going to multiply, let me do this in red so you can follow along. I'm going to multiply by x over 4x plus 3 on both sides. So this is x times 4x plus 3. So if you notice, these two x's will cancel here. So on this side, you're left with 4x plus 3. On this side, you're going to be left with 4x plus 3 times, actually no, this will cancel this way, my bad. So this is x times x plus 2. So, and now you just distribute, so you get x squared plus 2x is equal to 4x plus 3. I think the most difficult aspect of this for you might be just remembering what to do when, which is what everybody says to me. It's just I don't remember what to do when. So just follow your algebra instincts. Think of what should I do next. So this leaves you x squared minus 2x minus 3, and that's equal to 0. And at this point is factor, so you have, you can always use the quadratic formula. It's always a winner. Since this is a negative and that's a positive, this has to be the result of a negative 3 and a positive 1. So two solutions are x is 3 or x is negative 1. And so you notice this is a negative. That's not going to work. The solution will be 3. All right. So let's just take a look at that. If you want to discuss it, let's talk about it. And then if you're ready, I would like for you to try natural log of x minus 3 is equal to the natural log of 7x minus 23 and then minus the natural log. Let me switch pages. This is getting overwhelmed. Give me 1 second. All right, here we go. So let's try this again. So this is the try part. So natural log of x minus 3 is equal to the natural log of 7x minus 23 minus natural log of x plus 1. So think about the rules. You see a negative here. Immediately I would be thinking, so natural log of x minus 3 has to equal the natural log of the quotient 7x minus 23 over x plus 1, correct? These natural logs are canceling. That cancels with that. Okay, now we're just at a basic algebra question. It's not that tough. You could even flip them around. So I like working like this, so in this direction. So it doesn't change the value, but it just makes me more comfortable. Remember, this is technically over 1. So if you take the whole thing and multiply by x plus 1 on both sides, if you notice what's going to happen is this is going to cancel with that, leaving you 7x minus 23 is equal to basically a trinomial, because once you do FOIL, x times x, x squared, inner, outer, that leaves you negative 2x minus 3. Subtract the 7x and add the 23. subtract the 7x, and add the 23. So this gives you 0 is equal to x squared minus 9x plus 20. Two numbers that will add up to give you negative 9 but add up or multiply to give you 20 would be x minus 5, x minus 4. Your two solutions are x is 5, x is equal to 4, and guess what? Those are your two solutions. Once you substitute them, you can prove it. I actually should be in always in numerical order, so let's go with 4 comma 5. Okay. All right, so this is the try question for number 8. Number 8. All right, examples 9, 10, and 11. The only one that really interests me to cover with you, because the other two, 9 and 11, are just substitution. So let me just do 9 first. So number 9. So I'm going to read it to you. This has to do with alcohol and risk of a car accident. And basically, they have a model which says that the risk is modeled at 6e raised to the 12.77x. And the x is part of the exponent. Their question really sits at where x is, as a result, x is the blood alcohol concentration. All right, and R is the risk. All right, and then what you need to understand is they're going to express the risk in terms of a percentage, but you're going to plug it into the equation differently. So what they're saying to us is the following. They're saying where X is the blood alcohol concentration, where R is given as a percent, right? And is the risk of having a car accident. The question says what blood alcohol, I'm just going to do blood alcohol concentration corresponds to a 17% risk of a car accident. Okay, and so we are going to say that R is equal to 17, not 17%. That's the key in this question. At this point, it just becomes substitution, which is my point. So 17 is equal to 6e to the 12.77x. So step 1 is basically we're going to divide by 6 and bring it to this side, so that cancels. We are left with 17 over 6 is equal to e to the 12.77x. Remember, we're solving for x. What you do when you have these situations that there is no other way to go but to take the natural log of both sides, you are left with the natural log of 17 over 6 is equal to 12.77x. Remember, that's because these two always cancel each other out, and that's what you're trying to do. Once you finish this part, we're going to divide by 12.77 on both sides. Obviously that becomes 1, right? So all of this is what is equal to x. When you throw this in a calculator, which I'm going to give you a second to test, you should get 0.08. Okay, and so what this represents now is that for a blood concentration of 0.08, the risk of a car accident is 17%. And they also give you a little graph to follow. So let me do 11, because 11 is not as important, in my opinion, as another substitution. Just substitute and work it out. This is revisiting the height of children. If you remember, we had a model which was f of x is equal to 29 plus 48.8 log of x plus 1. Where x represents the boy's age from 5 to 15. I don't know if you remember this from a couple of days ago. So they want to know what age. This is the question in this one, in this style. It says, what age, rounded to the nearest year, has a boy attained %85 of his adult height. Okay, and so remember, we're given a model, so we are going to use that model. 85% is a number of interest for us. So we know that that is the f of x. So we're going to say 85 is equal to 29 plus 48.8 log of x plus 1. So like I said, it's basically math at this point. And so the first thing you're going to do is we're going to subtract 29. Right, and this leaves us at this point 56 is equal to 48.8 log x plus 1. So next step, obviously, we're going to divide by 48.8 on both sides. Yeah, 48.8, so that'll cancel. 48.8, so really, we're going to divide by log after this. So this is going to become 56 over 48.8 is equal to log, and this time we're going to remember that's a base 10, x plus 1, right? And so if you remember the backward C, this becomes 10 raised to the fraction 56 over 48.8 is going to be equal to x plus 1. So that it's just reverse, left to right, right to left, right? And so the last step is going to be to subtract 1 on both sides here. So now you have 10 raised to the 56 over 48.8 minus 1. And that's equal to your x. When you throw this in a calculator, because there's no human way to actually know that unless you're a savant, which not even savants, your age would be approximately 13 years of age. And so you can understand that this is basic substitution. I don't consider this to be a difficult question, okay? Now, the question that I do think is of value to you is question 10. So I'm going to do this one here. This is example 10. And of course, it has to do with the compound interest. And so the idea here is we have future value is equal to present value times 1 plus r over n raised to the nt. The trick to these questions, or the key to these questions, is that we're finding t. That's what makes it so interesting to us. And so in this example, this is what they tell you. It says, given the formula, this described the accumulative value A of a sum of money P, the principal, after T years at annual percentage rate, which is in decimal form, N times compounded in a year. How long, so this is your question, how long will it take $25,000 to grow to $500,000 at 9% annual interest compounded monthly. Okay, now compounded monthly means that n is equal to 1. And then in this case, they're telling us the interest, 9%, so that's going to be 0.09. We're now going to look at 25,000, that's your present value, so that's a p-value, and this is your annual value or future value. And so when we throw this into our formula, which let me squeeze it this way, this will become basically 500,000, which is what we want it to become. That's equal to 25,000 times 1 plus 0.09 divided by 12 raised to the 12 times t. We're looking for t. Okay, and so again, that's the focus of these types of problems. And so step 1 obviously is we're going to divide all of this by 25,000. When we divide by 25,000 on both sides, I believe we get 20. So this is going to give us 20 is equal to. Now if you do this math first, I would recommend you do this part first, then add the 1. I believe that becomes 1.0075. So 1.0075, because remember this all canceled, raised to the 12t. And so we're back at that situation where we have, we're solving for an exponent. So I don't have any bases that are equal to. So guess what? I'm going to put natural log in front of both of these. Now, this puts me at natural log 20 is equal to natural log 1.0075 12t. So now I can employ the power rule. I'll bring this forward. So I have natural log 20 is equal to 12t times natural log of 1.0075. Remember, I'm solving for t. I could simply just divide by 12 natural log of 1.0075 on both sides. So 12 natural log 1.0075. And if you notice, these are going to cancel. That's going to cancel. That's going to cancel on this side, leaving you just t. So now just use your calculator. So t is equal to the natural log of 20 over 12 natural log of 1.0075. And you end up with approximately 33.4 years. All right, and so there is a second example for you to try, but I'd rather you just do it in your homework because it's much more streamlined in the homework. You can see the charts and everything that they gave you, and so you do your try questions in the homework for all 3 of those, because like I said, the first 9 and 11 are just substitution. And this one is a little bit more involved. Yes, it's substitution, but it's of all three of those, I think the more important for you to learn, because we all need to learn about finances. All right, so that is 4-4 in a nutshell.